Pythagorean triple is when all three sides of a right triangle are whole numbers. Pythagorean triples will come in handy. It saves you from having to do the Pythagorean theorem to solve for a missing side if you notice that two of the sides that you're given are two of the sides in a Pythagorean triple. We use a lot of these to help us come up with problems that are solvable when we're designing problems. We use a lot of 3, 4, 5s, 6, 8, 10s, 5, 12, 13s. If you memorize the ones at the top, then you'll notice that you can multiply them by 2 or 3 or 4 or 5 or 10 and get another set of a Pythagorean triple. So the main ones that I memorize are the top row, and then I always kind of notice the 3, 4, 5s, how they're doubled or tripled or things like that. The Pythagorean theorem is when you have a right triangle that a squared plus b squared equals c squared. We're going to try to be in the habit of putting c on the left side when we do the Pythagorean theorem, just because when we're doing the converse, which is new this year, if you have it on the left side, it's going to, you're going to need it on the left side to tell if it's acute or obtuse. So that will help you if you get in the habit of putting c squared on the left. I'm going to work out some basic Pythagorean theorem problems here. The hypotenuse of a right triangle has length of 12. One leg has length of 6. What is the length of the other leg? So I'm just going to kind of draw a sketch of a right triangle here. They said the hypotenuse is 12. That's across from the right angle. One leg, 6. Of course, watch for your units here. They didn't say centimeters or anything, so we're okay so far. And then we're trying to find the other leg. So we're going to plug this into Pythagorean theorem. A squared plus b squared equals c squared. Hypotenuse is the c squared. So 6 squared plus x squared equals 12 squared. So 6 squared is 36. 12 squared is 144. So plugging that in, then we're going to subtract 36 from 144, gives us 108. So we see that x squared is 108, not 180. If I can talk and write at the same time, that would be good. 108. And then we're going to square root to get x alone. We do want simplest radical form, so when we're square rooting 108, it's like 2 and 54. 54 is 2 and 27. 27 is 3 and 9, and 9 is 3 and 3. We've got a pair of 3s, we've got a lonely 3, and we've got a pair of 2s right here. 2 times 3 makes 6, with the leftover 3 inside. So the missing leg is 6 root 3 units. So we do want to have simplest radical form unless they tell us otherwise. Question 2 says a triangle has side lengths of 16, 48, and 50. Is the triangle a right triangle? And explain. So we're going to check out if it works for Pythagorean theorem. So I'm going to plug it in the normal order. A squared plus b squared. C, of course, would be the longest number, so c squared there. So plugging that in, 16 squared is 256. 48 squared is 2304. And 50 squared is 2500. And so when you combine these over here, you get 2560, which is not equal to 2500, so it is not a right triangle. So it's not a right triangle because it doesn't work in the Pythagorean theorem. That would be my explanation. Now, number 3 here, we are finding a third whole number such that the 3 numbers form a Pythagorean triple. But the thing is that they did not tell you if you're finding the hypotenuse or you're finding a leg. So I am going to show you this first one, and I'm going to show you finding as if we're finding a leg and as if we're finding a hypotenuse, just to show you the two options that you have here. Our goal is to have a Pythagorean triple, so we are required to end up with a whole number. So if we think that we're missing a leg, then we would have a leg like a squared B would be like the 20, and then 21 would be the hypotenuse because that's the longest one that we have right here. So we would plug this in, and we would get a squared plus 400 equals 441. And we would continue solving and get a squared equals 41, and then when you square root 41, you do not get a whole number. So we would get a leg of about 6.403. Well, this is not a whole number, so it does not work for a Pythagorean triple. So we are not finding the leg. So then we would have to test finding a hypotenuse, and then hopefully the hypotenuse will be a whole number. So testing for a hypotenuse would be setting up 20 squared plus 21 squared, and then in this case we're finding c squared. So it's pretty much like guess and check, but there's only two choices. So when you add these together, 841, and then when you square root that, you get 29. So you do get a whole number when you square root in this part, so 29 is the missing number that you need to make it a Pythagorean triple. So we would like for you to try the one on the right side on your own.